Right, so we'll look at a few real basic problems first in word problems. These are some really straightforward ones just to get you used to coming up with a let statement and coming up with the other expressions in step two of your word problem solving. Now, the first challenge coming up with a let statement, sometimes this is easier, sometimes it's a little bit harder. Like in this question here, a good technique that would work is in the word problem, if you're looking, it's not obvious what a let statement would be to use. You can look at the last question at the end of the problem, and often that'll give you a good hint as to what a good let statement would be. So in this case, how old is Jessica? Then, well, let J be how old Jessica is. I'm using the letter J instead of X just because that reminds me who I'm dealing with here. So if I say let J equal Jessica's age, then I have a let statement. In this word problem, you'd probably want to use let M be Michael's age for reasons that we'll see in a second. But if you start off with let J be Jessica's age, you'll do fine. So let's do that. Let J represent Jessica's age. Now, when you're coming up with a let statement, this one's good because I don't just say let J equal Jessica, or let J represent Jessica. Because Jessica isn't a number, right? And this is a problem where it's a quantity I'm looking for. It's a number I'm looking for. And if I just say Jessica, I might forget what it is that I'm exactly doing. But if I'm a little more specific, which isn't tough here, just saying Jessica's age, that's going to help me make sure I know what I'm talking about. Step one, my let statement, let J be Jessica's age. Now, step two, and this is probably the hardest part of these word problems, step two is coming up with the other things in this word problem that aren't fixed quantities yet, that aren't set numbers yet. And in this case, this is a pretty simple word problem that we're starting off on. So there aren't a whole lot of things that we don't know. We don't know Jessica's age. And if you're looking here and saying, well, I know the sum of their ages is 40. I know how far apart they are in years. It's 12 years. The one thing that I really don't know is how old Michael is. And if I read this over 5 or 6 times, I'm sure I'll eventually figure out that that's one of the other things that's missing. So when you're coming up with your other expressions here, you don't need to do let blah, blah, blah. The let statement is really saying this letter means this. For the rest of this problem, I'm telling you this. So the other expressions that you'd come up here, you'd say like, well, if Jessica is J years old, then I have to write an expression using J that will tell me how old Michael is. Now Michael's 12 years younger than Jessica, right? Jessica's 12 years older than her brother Michael. So a lot of students have trouble right here because they want to do something like, is that like J divided by 12 or 12 times J or something like that? The right one here is J minus 12 is Michael's age. And if you're saying to yourself, well, I'm not sure I'd be able to come up with that on my own on a test, say to yourself, let me pretend I actually knew what Jessica's age was. This letter stuff here in algebra might be a little tough for you to say. Let's say I knew that Jessica was, 50 years old. I mean, she's not in this problem. It's impossible. But let's just pretend I knew when she was 50 years old. You say to yourself, well, if I follow the rules of the problem, she's 12 years older than her brother Michael. If she's 50, then I guess that means that Michael would be 38. And usually we're pretty good at coming up with that math on the top of our head, saying like, okay, well, Michael's 38. Now, once you do that real quick, what I want you to do is go back and say to yourself, what is it I just did to get that Michael was 38? And you say to yourself, well, I said 50, and then if she's 12 years older, and I took 12 away from 50. Aha! So what you did was you took 12 away from her age. Right? If you see yourself doing 50 minus 12 to get an age of 38, say to yourself, okay, if that's what I would do if her age were 50, then let me just replace her age here with what the let statement says her age is, which is J. And so then instead of 38, which is just a fake number that we made up for Michael's age, we have the expression for Michael's age is J minus 12. Okay, once you have your expressions, step two, often there's many expressions here, not just one, but 2, 3, 4, 5, 6 sometimes in some problems. Now, once you've got those taken care of, you want to move on to step three, which is writing your equation. In this case here, usually in coming up with the expressions, you've used up a lot of the information in the problem. When you get to step three, coming up with the equation, you say to yourself, is there any information I haven't used yet? Jessica's age is not really a piece of information that's taken from the problem yet. J minus 12, that's me using this whole sentence here that she's 12 years older than Michael. And the piece of information I haven't used, the sum of their ages is 40 years. If you notice that there's something you haven't used yet, usually that's going to show up in your equation. So the sum of their ages is 40 years. That word is, it's often a hint that you should have an equal sign there. So is 40 years. Think of that as an equals 40 years. And I just have to put on this side of the equal sign something that's the same as on the right side. This is the sum of their ages over here, 40, right? The problem tells me that 40 is the sum of their ages. So on the other side, I have to put the same thing. What is the sum of their ages? Well, let me use the algebra to express that. This is her age, this is her brother's age, and sum is just adding those two together. So this is my equation. Once you get here, usually the problem is in good shape because you've done the hard work. The real thinking happens around here. Now it's just a matter of solving the equation, which wouldn't be too long. First you'd say, all right, I got to get rid of those brackets somehow. In this case, they don't really do much in the problem. They're just a reminder to yourself to, if there's a subtraction, they'll become really important. Here they don't really. So I just get rid of the brackets first, and then I look for like terms. So I could add the two j's together. So I have 2j minus 12 equals 40. And then I add 12 to both sides. I have 2j equals 52. And then I divide both sides by 2 and I have j equals 26. Now once you do all that in step 4, you haven't finished the problem, right? You still got to say to yourself, does my answer make sense? If Jessica is 26, that's what my let statement is telling me J is. J is 26. If J is 26, then Jessica's 12 years older than her brother Michael. That means he would be 14. The sum of their ages is 40. I want to check. Does 26 and 14 together add up to 40? Yes, it does. Okay, so it looks like I've got the right answer. But in order to finish the problem, because it's a word problem, I have to actually answer the question here with a sentence. How old is Jessica? This isn't going to be a very elaborate answer. Just Jessica is 26 years old. I'm including the units here. Notice years is actually units. She's not 26 days old or 26 months or whatever it is. And that's my answer, my step 5. Jessica is 26 years old. All right, let's look at another one here. First, let me clear off my plate, get this clean. I'm moving on to another question. Again, similar level of difficulty. Eric is 3 years younger than his sister, Caroline. The sum of their ages is 35 years. How old is Eric? This one sometimes gets people because they see, well, Eric is 3 years younger than his sister Caroline, so they do things like, okay, let me get a let statement here. Let E represent Eric's age. Usually you shouldn't use the letter E in a let statement, but I wouldn't worry too much about it at this point, okay? Because E is actually a number, which you guys haven't seen yet, but it's a real number. So step 1, let E be Eric's age. And then you say to yourself, all right, once I've got my let statement taken care of, what are the other quantities in here that I don't know? I know there's some of their ages 35, so that's not something I don't know. I know the difference between them in years is 3 years. That's not something I don't know. But I don't know Caroline's age. So let's come up with Caroline's age. Caroline's age is what? Where people have trouble here is they'll say, Eric is 3 years younger than his sister Caroline, so E minus 3 gives me Caroline. That's not what it's saying. Eric is 3 years younger than his sister Caroline. What that actually means is Caroline is 3 years older than Eric. Now, if you're saying to yourself, well, it doesn't say that in the problem, that's just something I'm saying by adjusting the words here. If it makes it easier for me to understand, that's what I'm going to do. This is often for people a little harder to write an expression for than just saying Caroline's 3 years older than Eric. Because then I can just write, well, 3 years older, that's easier for me to think of. It shouldn't be any easier or harder. It's just the same mathematical concept. But for whatever reason, it is harder to think in terms of Caroline being, Eric being younger than Caroline, right? Like, should I do 3 minus E, some people might come up with? No. Turn the words around in the sentence so it makes sense to you. Caroline's 3 years older than Eric. Again, if you're not sure if the numbers are working for you, try plugging in real numbers. Say to yourself, okay, let's say I knew that Eric is 25 years old. And if you knew that Eric was 25, you wouldn't have any trouble figuring out how old Caroline is. Eric's 3 years younger than his sister. Well, if he's 25, then I guess she's 28, right? That makes sense. And then you say to yourself, what did I do with the numbers to get from Eric's age being 25, which is E, right? That's what this 25 is standing in for, this random number I made up. What did I do to get from 25 to 28? The answer is, you see, well, to get from 25 to 28, I'm adding 3 to get there. So once I see what I would do with numbers, then I say to myself, okay, well, then I can just forget about these made up numbers that don't actually matter and just replace that 25 that was there, which was a made up age for Eric, with the letter that stands for Eric's age, e plus 3. And that's how I know I have the right expression here. Okay, once that's done, now I just got to come up with an equation. Remember, for an equation, you're always trying to put two things on either side of the equal sign that are the same as each other. And the other thing you want to watch for, is there any information in this problem yet that I haven't used? I've used that Eric is 3 years younger, but I haven't used that the sum of their ages is 35. So the sum is 35. That means I can put 35 on one side and the sum of their ages on the other. How do I write a sum? Well, sum is addition, so I just got to put their two ages in here. Caroline's age and good old Eric's age. Happy birthday, Eric, by the way. Congratulations on turning whatever age. We'll soon find out you just turned here in a second. So that's your equation. E plus 3 equals 35. And again, that's the hard work of the problem already done. Now we just have to solve the math here, which is not too challenging in this problem. Right? We just have to get rid of our brackets first, and we add like terms together. You want to make sure, it's tough for me to do with this keyboard here, but you want to make sure to line up the equal signs. And now you get E isolated, right? You want to get E all alone by, in this first case, subtracting 3 from both sides and then dividing both sides by 2. So when I divide 32 by 2, I get 16. Now, I always want to make sure when I did all this, did I get everything right? I've got this number E equals 16. Let's see if that works. If Eric is 16 and he's 3 years younger than his sister Caroline, that means that Caroline's 19. If Eric's 16, Caroline's 19, is the sum of their ages 35. 16 plus 19 gives me 35. Good. All right. I'm satisfied that I've got the right answer. Now I just have to write a sentence. How old is Eric? Eric is 16 years old. That's my sentence answering the question. Let's do one for these, a third problem here on the basic level. And then that'll be the last one I'll do for this